today's video I am going to explain how to find out the adjoint of the matrix. In my previous video I have given solution for the first question, and this topic is from Matrices and Determinants and it is related to the Diploma Mathematics 1. So this question I have explained and the rest of the questions I am uploading today, and thank you so much for having trust in this channel. And the second question here is, so we have to find out the adjoint of the matrix. For finding the adjoint of the matrix, as usual, so first of all we have to find the cofactor of the matrix. So first of all we have to find the cofactor of the matrix. The transpose of the cofactor of the matrix is nothing but the adjoint of the matrix. So we have to transpose the cofactor. And how to find the cofactor of the matrix? Cofactor of each and every element is equal to -1 power row number plus column number into minor of each element. So for example, if you take this matrix, so this is row 1, row 2 and row 3. So these are column 1, column 2 and column 3. And so this is the position. So this is row 1, column 1, 1, 1. So this is row 1, column 2, that is 1, 2. And row 1, column 3, this is 1, 3. And here this is row 2, column 1. So likewise I have completed all these. And here, so this is -1 power row number plus column number. So if I add up 1, 1, 1, 2, 1, 3, and here after adding up all these row numbers plus column numbers, and so this is the result. So plus, minus, plus, and minus, plus, minus, and plus, minus, plus. And after getting this, so we have to multiply this one with the minor of each element. So how to find the minor of each element? So for the second question I am explaining you. See here. So this is the first one here is 1, 1, 1. See here, this is 1, 1, 1. 2 minus 1, 3. This is 4, 0, 5. So we have to find out the minor as well as the cofactor. First of all, I am going to find out the cofactor of the matrix. So before that, we have to multiply each and every term with plus, minus, plus. Plus, minus, plus, and again minus, plus, minuses. So after minus, this will be plus, minus, and plus. So I said you how we got this one. -1 power row number plus the column number. And the next one we have to find out. So how to find out the minor of each element? So the position here is, this is A11, this is A12, this is A13. So this is B, this is row 2 and column 1, and this is row 2 and column 2, and this is row 2 and column 3. And here this is row 3, column 1, this is row 3 and column 2, this is row 3 and column 3. And for this position we have to find out the minor. So this is A11. So first of all, what is A11? So for finding A11 we have to close, so this position, that is row and column. So after closing this row and column, so this is -1, 3, this is 0, 5, and the next one is first row and second column. So this is first row and second column. So if I close this, this will be 2, 3, 4, 5. So this will be 2, 3, and this is 4, 5. And the next one is A13. So for A13, see, so this is A13 position. So we have to close this row and column. So this will be 2 minus 1, 4, 0. So this will be 2 minus 1, 4, 0. And the next one here is B11. So this is B second row, first column. So this is B21. So now I have to close this row as well as this column. So after closing this row and column, what remains? This is 1, 1, 0, 5. So this is 1, 1. This is 0 and 5. And the next one, B22. So for B22, see, so here it is B22. So now I have to close this row as well as this column. So after closing this row and column, this will be 1, 1, 4, 5. So this is 1, 1, this is 4 and 5. So this is B23. So for B23, so this is the position. Now we have to close this row as well as this column. And what remains here? This is 1, 1, 4, 0. So this is 1, 1, 4, 0. And the next one, the position here is C31. So for C31, so now we have to close this column and this row. and this will be 1 1 minus 1 3. So this is 1 1 minus 1 3. So this is 1 1 minus 1 3, and the next position is row 3 and column 2, and here if you observe, so now I have to close this one. So this will be 1 1 2 3. So this is 1 1 2 3, and the next one is 3 3. So this position is nothing but 1 1 2 minus 1. So this is 1 1 2 minus 1. Now we have to find out all the values here. For finding all the values, so this is minus 5 minus 0. So the value here is minus 5, and here this value is 5 to 2 5s are 10 minus 12. So this value is minus 2, and here if you see it is 0 and minus of minus plus 4, the value is 4. So this is AD minus BC. So here 1 into 5, this is 5 minus this value is 0. So here the value is 5. And if you observe, this is 5 ones are 5 minus 4, the value is 1. And here this will be 0 minus 4, the value is again minus 4. And here this value is, this is 3 minus of minus plus 1. So the value is 4 here. And the next one, this value is 3 minus 2, the value will be 1. And see here, this is minus 1 minus 2, so the value is minus 3. Now I have to multiply each and every element with the minor of each element. So the minor of the A11 is nothing but minus 5. So this will be minus 5. And the next one, A12. So the minor here is minus 2, and already we have to multiply with minus. So this will be plus 2. And here A13. For this position, the minor is nothing but 4. So the value here I am writing, that is minus 1 power, that is a row number plus column number. This is plus into the minor of the element. This is 2 B21. So here it is 5, and this value is 1, and this value is minus 4, and this value is minus 4, and after that C31. So for this position I have the minor as 4, and this value as 1, and this value as minus 3. Therefore I got, so this is nothing but cofactor of the matrix. So I got the cofactor of A as, see here, this is minus 5 2 minus 5 2 4, and again this is minus 5 1 4, and this is 4 minus 1 minus 3. So this is the cofactor. And after finding the cofactor, then the adjoint of A value will be, the adjoint of A is nothing but cofactor transpose. So the cofactor of A transpose. So now I have to change the rows into columns. Here the column 1 will become the row 1, that is minus 5 4, and this is 2 1 minus 1, this is 4 4, this is minus 3. So this is nothing but the adjoint of A. So this is nothing but the adjoint of A, and this is how we have to calculate. And this is so simple if you understand. So this is minus 5 4, this is 2 1 minus 1, this is 4 4 minus 3. And the next one, if I proceed like this, so I'll be getting the answer for the second solution so soon. And here, so for the third question here, the third question is nothing but 0 3 1. So first of all, A is given as, this is 0 3 minus 1, this is minus 4 2 3, and this is 5 3 7. So now I have to calculate the cofactor. So before that, there is a formula that, so we have to go with plus minus plus, and minus plus minus, and this is plus minus and plus. I said you how we got this plus minus. So this is nothing but minus 1 power row number plus column number, minus 1 power row number plus column number. So these are all the positions of any matrix, and this is how we got plus minus plus and so on. So with this we have to multiply with the minor of an element for getting the cofactor. After getting the cofactor, the transpose of the cofactor is nothing but the adjoint of the matrix. So now I am going to find out the minor of each element. So the position here is A11. So here the A11 value will be, see, I'll tell you, A11 value is nothing but. So now I'll close this row as well as this column. So if I close this, this is 2 3 3 7. So this is 2 3 and this is 3 7, and the next one, row 1. See here, this is row 1 and column 2. So this value will be, so row 1 and column 2. So I have to close the second column and row 1. This will be minus 4 3, and this is 5 7, and the next one A13. So for A13, see, so this is the position of A13. Now I am closing the corresponding row and the column. So this is minus 4 2 5 3. So this is minus 4 2 and this is 5 3. And the next position here is B, second row and first column. So this will be C. So second row and first column. So now I'll close this one. So after closing this, this will be 3 minus 1 and this is 3 7. So this is 2 2. Second row, second column. Now I have to close the second row, second column. 0 minus 1 5 7. So this is 0 minus 1 and this is 5 7, and the next one is 2 3, and this will be, see here, this is 0 3 5 3. This is 0 3 and this is 5 3, and the next one, column. So this will be, the position here is a C3 and column 1. The position here is, if I close this row and column, this will be 3 minus 1 2 3. So this is 3 minus 1 and 2 3, and C3 2. So if I close this row and column, see what happens, 0 minus 1 and this is minus 4 3, and C3 3, the value here is, now I have to close this one. So this will be 0 3 minus 4 2. So these are all the minor of the element. Now I have to find out the values. For finding the values, you see, so this is 14. 2 7s are 14. So this is 14 minus 9. So this will be 5. And here if I multiply, so this is 4 into 7. So this is minus 28 minus 15. So this is minus 43. So this is minus 43, and the next one here is, this is minus 12. So this is minus 12 minus 12. This is minus 22. So this value is minus 22. And the next one here, this is 21 minus of minus plus 3. This will be 24. And here this is a 0 plus 5 and this value is plus 5. And this is a 0 minus 15. So this is minus 15. So this is 9 minus of minus plus 2, so this value is 11. And here this is 0 minus 4 and this value is minus 4. And see here, this is 0 minus of minus plus 12. So this is 0 minus of minus 12, this is plus 1. So I got all the values here. Now I'll substitute here. So in the position of A11 we have 5, and in position of A12 we have minus of minus plus 43, and this is the value of A13. So this is minus 22. So this is minus 22, and the next value here is 24. B21, B22 value is 5, and the next one, this is minus 15, and the next one here is, this one is 11, and this value is minus of minus plus 4, and this value is 12. So I got the cofactor of the matrix, and after finding the cofactor, so I got cofactor of A. So cofactor of A is nothing but 543 minus 22. This is 543. This is minus 22. This is minus 24, 5, and this is 15. And the next one, 11, 4, 12. So this is 11, 4, and this one is 12. So after finding this, adjoint is equal to, so adjoint of the matrix A is nothing but cofactor transpose. So we have to transpose the cofactor of A. So adjoint of A value will be, now I have to transpose this. So for transposing we have to change the columns into rows. So this is column 1, I am writing it as row 1. So this is column 2, so this will become row 2, and this is column 3, I am writing as row 3. So this is 12. So the answer here is 5 minus 24 11 and 43 5 4, and this is minus 22 15 12, and this is how we have to solve, and this will be so simple if you follow the small steps. Thank you so much for watching and staying till the end.